Hey y'all. Yesterday we did the simple epithelia and today we have to do the stratified epithelia. If we go back to the picture here, just to remind ourselves that simple epithelial tissue only has one layer of cells and those cells are kind of packed together side by side by side. Whereas stratified epithelia is going to be one layer of cells and then another layer on top of that and another layer on top of that. Sometimes it's only two layers. Sometimes it's just like this stratified cuboidal where you have two cuboidal cells on top of one another. Other times, like in stratified squamous, it can be many layers of cells, 60, 100 layers of cells, just depending on what tissue you're looking at. So the first one that we need to do is pseudo-stratified columnar epithelium. And the stem pseudo means false, and that's going to be your giveaway with this tissue, because if it is falsely stratified, and that means, well, it may appear stratified, but it is not. Okay, so it is actually a simple epithelium, meaning that it only has one layer, but it is going to appear as if it has many layers. It is columnar, so the cells are going to be longer than they are wide, and the way that the columnar cells pack together, it's going to squeeze the nuclei at different levels, and the nuclei are going to be kind of all over the place, just based on how tightly packed those columnar cells are. Pseudostratified is also ciliated, meaning that it has cilia on top of the columnar cells, or at the apical side of that epithelium. And the cilia are there to move. Remember that cilia are longer than microvilli, and they move, whereas microvilli are short, they do not move, and their purpose is absorption. You will have this pseudostratified columnar epithelium in your respiratory tracts and in your reproductive system. So this would be found in your nose, in your throat, in your trachea, and the purpose really is just to move air and move mucus throughout the respiratory tract. In the reproductive tract, it's going to be good for moving sex cells or moving an egg in the female reproductive system. The function is protection. It's protected because it's got this goblet cell here, and that goblet cell is going to produce mucus. Also, that follows with secretion. It's going to secrete that mucus onto the cilia. If you've ever had a really nasty cough or that wet cough that you can hear the mucus moving around, those goblet cells just kick into overdrive and make more mucus, and your body's trying to expel that by coughing, and those cilia are trying to sweep it out. If you look at this picture of pseudostratified, this is a better image than the one on the previous page, but first thing I notice are the cilia. Okay, if there are cilia, then it is pseudostratified. Okay, that's just the name of the game. I will not give you a pseudostratified epithelium that does not have cilia. So the first giveaway is cilia. Now, if it's zoomed really far in like this one, then the cilia are obvious. If it's zoomed really far out, they may not be. So you've got to have a way to double check yourself that this is pseudostratified columnar versus simple columnar. And so the next thing to do is to look at the nuclei. And you can't really lay a pencil down or draw a line across these nuclei and kind of hit all of them at one time. There's going to be nuclei at many different levels within this tissue. And it doesn't mean that there are more than one nucleus per cell. It just means that those cells are so tightly packed that the nuclei get pushed wherever they can fit. And so the second way to check yourself is to look for the nucleus and see, well, is it kind of zigzag pattern? Are the nuclei all over the place, or are they at one level? Let's go back to simple columnar for a second. I can take my pencil and lay it down on the paper and cover up those nuclei. Or I can draw a line and it's basically going to hit every nucleus. Whereas in pseudostratified, you cannot do that. Remember that the connection between the epithelial tissue and the connective tissue is right here. Okay, and that would be your basement membrane. That basement membrane is sticky, but it's also semi-permeable. You want to have some kind of passageway of nutrients and oxygen in through that basement membrane. And underneath the epithelial tissue, remember that you've always got connective tissue, because epithelial tissue cannot exist alone. It has to be buddied up with this connective tissue underneath because it has to have blood supply. The epithelial area up here is avascular, meaning that it does not have blood vessels, whereas down here in the connective tissue, you do have the blood supply for the epithelial cells above. The second tissue that we'll do today is stratified squamous. And stratified squamous is your first, for real, stratified epithelium. And it is composed of many, many layers. And those layers can be seen here in the dark purple. Okay, we're going to look at another picture of it, but this light purple down here is connective tissue where you see this bracket. That is stratified squamous epithelium. The important thing to note here is that the function is protection, and that's because you will have stratified squamous epithelium in areas where there's a lot of friction and where there's a lot of abrasion. And so think about your skin. The outer covering of your body is stratified squamous epithelium. And as skin cells are falling off, we need more underneath to protect that boundary that is created by your skin. And so if one cell falls off here at the top, it's no big deal because there's a whole bunch underneath. It's also no big deal because the cells down here closest to this basement membrane are constantly undergoing mitosis. And so the cells at the basal surface are actually cuboidal shape. They have this cube appearance to them. The nucleus is in the center. And as the cells move through the column, they're going to become flattened, and they're actually going to get rid of their nucleus. So that when they fall off, that's okay, because not only are the cells down here making new ones, but there's 20 or 30 layers of cells underneath the top layer. So what will happen is these cells down here undergo mitosis. The simple cuboidal cells down here at the basal surface will undergo mitosis, and they will push those cells, the old cells, up and up and up and up. So it's just this wheel of mitosis that will make a new cell and push those old ones up and up and up until eventually they fall off. That process only takes about 28, 35 days, somewhere around in that time period, where you completely shed and regenerate those cells. Here's another picture of stratified squamous. I like this one a little bit better because you can see the nuclei, and the purple and the nuclei kind of blend in. But let's start with what we know. We know we should expect to see many layers of cells, and I do. Okay, so I can kind of dot in the nuclei here to show you that the cells are stratified, or the tissue is stratified because the cells are stacked on top of one another. Okay, and it continues to go up until about right here we don't have any more nuclei. They're completely disintegrated. The cells down here at the basal surface will be cuboidal in shape. Okay, that's just the way that they start out. And as they get packed, they're going to become super flat cells. So the cells up here at the apical surface are squamous cells. And the cells at the basal surface are cuboidal cells. Okay, still classified as stratified squamous epithelium, but the ones at that basal surface just get a cuboidal shape first. Okay, again, the connection between all of the epithelial area here and the connective tissue underneath is the basement membrane. Sticky and semi-permeable. And then under the basement membrane is going to be your connective tissue anchor for that epithelial tissue. Okay. Now, one thing to note before we move to this next and last tissue of epithelial section is that up here, the whole thing looks flat. You can almost draw a straight line across the top. It can be kind of a wave or a mountain, but the actual line across the top is going to be relatively flat. On the next tissue that we look at, it won't necessarily be flat. And the distinction between this transitional epithelium that we're going to do and and stratified squamous is to look at that top portion of the epithelium. Look at that apical portion, because transitional epithelium is going to have very rounded, oval-shaped cells, whereas up here, because the cells are squamous and stratified squamous, it's going to create a flatter appearance. The last stratified epithelium that we have to do is transitional epithelium. And it's going to be stratified no matter what, whether the bladder where this is found is empty or full. It doesn't follow the typical naming pattern. So, we're used to stratified squamous, stratified cuboidal, based on the layers and the shapes. But this one is called transitional because it transitions between two states, a full and stretched state and a more relaxed and empty state. This is what transitional epithelium looks like in the body if the bladder were empty. And the cells at the apical portion are very large and they're very rounded. I think your textbook calls them ovoid or oval shape. So they are much, much bigger and they have a nucleus. Whereas in stratified squamous, you won't have a nucleus in every single cell at that apical portion. And as the bladder fills, okay, so here's a bladder picture. As that bladder fills with urine, so if we were to draw in some urine, it's going to put pressure against this apical portion of the stratified, of the transitional epithelium, and it's going to cause these cells to compact down on one another, and it will have a more stretched appearance. Then as the bladder empties, they just kind of fall back down to their normal shape. The only place in the body where you'll have this is the bladder. That ability to stretch and relax is called distensibility. If a bladder is distended, it is very full. And that's protective for that organ because it has to have a lot of volumetric change as the bladder fills and empties over and over again. We look at this picture here, you can see two comparisons of the stretched bladder or the full bladder versus the relaxed bladder. Either way, okay, let's do relaxed first. Either way though, the cells at the top are very rounded. Okay, you won't have that in stratified squamous. That one's probably two cells. You can't really see the cell membrane very well. But if the bladder is full and it is stretched, they're still rounded. It may appear a little bit flattened towards the top, but you gotta pay attention to those individual cells at the apical portion. Okay, typically pretty pink or purple based on the appearance or based on the stain. This would be your basement membrane through here. This is your connective tissue, and all of this here makes up the epithelial section. Okay, and that's all for stratified epithelium. Pretty easy, pretty distinct from one another. Now when we mix it with simple, you got to really pay attention to the shapes of the cells and then think about the locations and the functions.